G'day viewers. This will probably be my last video on quantum mechanics. I've gained a very great and clear understanding of the processes, which previous to this always had me quite confused. I understand quantum electrodynamics quite well, and I use it I use it quite often actually. But we'll talk about quantum mechanics, talk about protons, electrons, neutrons, neutrinos, and how they're all related, how energy and matter are interchangeable. Electricity and magnetism, they're not the same force. A lot of you people wrongly say electromagnetic theory. It is two separate entities, electrical and magnetic, and they are interchangeable. You can convert magnetism to electric flow, and you can convert electrical energy into a magnetic system. And what I've learned is Nikola Tesla left a very cryptic clue. He said, when you understand 369, and I took that to be, well, I looked at the three different wave propagation speeds, where you got three different types of waves, and that didn't fit. Then I looked at this three different forces that are underlying the entire universe. And I have to say that this is my theory, built on everyone else's knowledge, of course, taking relevant pieces of data and fitting them into a working model. And I found some very interesting facts. Well, I'm stating them to be facts. Well, we need them to be proven and ratified, and probably write a paper on it. And I am interested in writing a paper because finally it was very quick. Once it started falling into place, it became very quick and very apparent. The relationship between photons and neutrinos and energy emissions, and how photons all line up to form waves, and everything it was like a jigsaw puzzle. And it just a few people gave me different pieces, and too many people to name, going right back to Faraday and others, and Maxwell, and I formed a complete view of quantum mechanics. Now, I know a lot of you people doubt that. I don't care. It's all about arguing facts and points and observations. And what I'll be looking for now is a qualified physicist to make sense of my data. It's quite simple. It's very simple when you look at the basics of it. And to test my understanding of knowledge. Maybe I have a flaw, maybe I'm correct, maybe I'm not correct. The point is, this is so profound that I have to put it out there. I am compelled to put my theory out there. And basically it just unites everything. And I have a complete and better understanding of quantum mechanics, which made no sense, and parts of it still make no sense because the people that are delivering the theories are coming up with just insane propositions that have no relevance to the physical universe. An example of this is if something has a greater probability than the length of the universe or the existence of the universe, well then it's not even worth mentioning such an act if the probability is too great. It's got to be discounted as irrelevant nonsense. But I found the numbers 369, three forces, three quarks, 6 gluons, 9 components to a proton, 3 components to an electron, or 3 pairs, 6 subcomponents if you like. I found it really, really interesting, and it's so simple. It predicts every possible outcome that can happen in the universe for particles. You know, your basic particles, your everyday particles that we live with, our protons, neutrons and electrons. Yeah, that's what solid matter's made up with, and you can smash them together and you can make up any number of I suppose the right term would be mush particles. You can make up any particles you want. But now that I have this more complete understanding, I'll be going back to my machine that I've been building over a year now. It works. It's quite destructive. The forces involved, over 1 billion Gs in physical force generated through electromagnetic energy. I won't tell you what I'm doing with it. A couple of people know. We've had some good results. But this is my last video on physics. There's too many people out there that are too negative. I find very little positive energy out there in the internet. There's not many real thinkers out there. So I won't be boring you with my outcomes and my theories. I'll go and write a paper on it and you can read about it. It'll take a couple of years to write it out, I suppose. Maybe a year at the shortest. And it'll come with the accompanying math and geometric analysis, and you know, you've got to take in your X, Y, Z coordinates and time and yeah, predicted and relative shapes. But it is really, really deep, and I'm really happy that I've come up with it. And I've got to thank a few people for giving me alternative perspectives and looking at the way that they've explained things. And you see, if you can identify the errors in any statement, well then you're on the pathway to truth. And that's all I'm after, is the truth of quantum mechanics. And it's a little bit harder than what most people think. So that's about it. I'm saying goodbye to physics on YouTube. I'll go and do some private work and develop it from there. And when we've got a white paper that's been peer reviewed, I won't go in, I won't release the shape of a photon, and it does have a shape, you can't deny it. It's carrying energy, it does have to manifest in a physical shape, whether it be an electromagnetic shape or electrogravitational or whatever you want to call it. It has a shape. Protons have a shape, they're not round. Electrons have a shape, they're definitely not round. They can't be round to be able to emit a photon for a start. There has to be differentials for the photon to be emitted. And just on a leaving note, talking about photons, it's very hard to collide two photons together. You really need really small photons, really high energy gamma photons, and then even then your chances of colliding two are incredibly small. But it does happen, it can happen, and it's been proven. So with that, I'll say goodbye to anybody that's been watching my physics videos. I'll be doing quite a few electrical ones on electrolysis of water and possibly some gravitational experiments. I'm very interested in that. And maybe some on synthetic crystal structures a bit later, where we're actually synthesizing crystals using high temperature plasma. So with that, I'll say goodbye to you physics people, and we'll go and do our own thing. So yeah, it's been fun. Catch us all later.